Okay, so today we're going to be looking at solving equations using multiplication or division methods. So it's very important to remember that multiplication and division are inverse operations of each other, meaning that one can undo the other. Um, so for example, if I multiply two numbers, say 2 times 3 and I get 6, if I wanted to undo that, then I would say, hey, take 6 divided by 3 and I get 2 again. Or take 6 divided by 2 and I get 3 again. Okay. If I wanted to divide two numbers and then undo that, so say if I took 8 divided by 4 and I got 2, if I wanted to undo that, I would say, oh, what's 4 times 2 again? Oh, yeah, that's 8. So I had originally. Cool. So that idea still holds when it comes to solving these equations. And we can use that to solve for our unknown variables, to find values for them. So let's take a look and see how that works. So in this first example, we have 9 times some unknown number is negative 6.3. I want to make sure that's real nice and bold for you. Negative 6.3. And our second example, we have some number divided by 2 equals 6. All right, let's take a look at the first one first. So some 9 times some number equals negative 6.3. Well, how would I solve that? Well, I know that if I take 9 times a number and I get a larger number, that means I took that value and I did it 9 times. So if I undo that, meaning that I split those groups up into groups of 9 or divide it, I'll find my answer. So that's what we want to do here. The inverse operation of that multiplication happening would be division. So we want to take this side of the equation and divide by 9. Well, there's a problem with that. It all has to do with this thing called balancing. There's a balance here. There's a scale. So if I were to divide one side into 9s, this will become off balance. But what I can do is the exact same on the other side, and now it balances out again. So that's exactly what I want to do. So I'm going to divide on 9 on one side, and I'll divide by 9 on the other. So that way my equation stays equal, stays balanced. Now I am writing division using fractions because that's what fractions are. They're just a division problem. So I'm dividing by 9. All right, well, 9 divided by 9, even if it's 9x divided by 9, we learned from simplifying that we can divide these as normal, and we get 1. So we have 1x. So I'm just going to put x because that's the same as saying 1x, right? So I don't see 1x there, so that's got to be 1x. Yes, it is. Okay, and now negative 6.3 divided by 9 will give us negative 0.7. And then we're done. Oh, look at that. That was nice and simple, right? Yeah. So when there's multiplication happening between an unknown and another number, we can just divide by the constant or the number in front of the variable here, which is actually called a coefficient. That is the actual mathematical term for it. So if you want to just call it the constant term that's multiplying times the variable, or if you just want to say that number in front of the x or the unknown, however you want to say it, that's fine. It's called a coefficient, so you'll hear me say that probably a lot in other videos. But we take this coefficient that's being multiplied times the unknown here, and we divide by it on both sides in order to find the unknown. Okay, so let's look at this other equation here. This time we are taking the variable and dividing by 2. Ooh, that's a little different, right? It is, but the process will be very similar. What is the inverse of dividing by 2? If I were to take something and split it into 2, how would I get back to what I had originally? Just put it together. Yeah, exactly. We're gonna put it back together. Well, how would I know how to put it back together? I mean, maybe it was so I had 4 candies and we split it up into 2, so I have 2 now. How do I get back to the 4? Oh, just go back and add it together. It's not adding it's adding it, but I'm just gonna double back what I had. So if it was say 6 items and I split it up into 3 and 3, how would I get back to what I had originally? Oh, I would double the 3. So I'm going to take this and I'm going to double it. In other words, I'm going to multiply both sides by 2. So I'm going to do 2 times x over 2 is the same thing as 2 times 6. Okay. Now when I do that, notice how this has the same setup as the other problem did. We have 2 times x over 2 equals, well, 2 times 6 is 12, so 12. And what happens with 2 divided by 2? It becomes 1. So we get 1x equals 12. How about that? That was pretty darn simple to do, right? Remember, math is simple. And we want to keep it simple. We don't want to make it look complex or become complex to us. Maybe it won't be necessarily easy, but it can be kept simple. And if it's kept simple, you take it one step at a time, it eventually will seem easier and easier. So, this is a method that you can use to solve equations that involve multiplication and division. To undo multiplication, we just divide by whatever the coefficient is. To undo division, we can just multiply by whatever it's being divided by, the divisor. All right. Now, there is another method that some people use when doing this. They write out what's happening and then they do the opposite, going backwards. So they would write out, hey, I'm multiplying by 9 to get this answer. So they would say, okay, I'm going to divide by 9 to get my unknown. Well, isn't that what we did? We took this and divided by 9? Yes, it is. I'm going to take my unknown and divide by 2 to get 6. Well, if I do the opposite of that, instead of dividing by 2, I multiply by 2. 6 times 2 equals 12. Isn't that what we got for our unknown? Yes, it is. So you can, when you're doing these, there are other ways to make it look even simpler, make it to see what's actually happening in, I don't want to say in the background, but what's actually happening mathematically. And I'll make it a lot easier to solve these. But many of you will probably be used to doing it this way, and you feel like, oh, that's the process, that's how you have to do it. No. If you want to say you know for certain that 9 times negative 0.7 is going to give you negative 6.3, and you know that for some reason in your head, and that's a number fact, that's great. Say that, and then say, well, x has to represent that then, because that is a number fact that I know off the top of my head. But if you were to say something like 9.873 x equals negative 2 point blah blah blah, and I know by a number fact that that is da-da-da-da. Like, come on, really? Do you just know that in your head? Maybe, but do you really? Or did you divide that, or did you just Google the answer? So be honest about it. But you're not here to try to show off or anything either. You're just here to find the unknown and to do it correctly. Because you want to be able to explain yourself to someone at a job, or even to yourself. Like, maybe you make a mistake somewhere and you're like, I don't know how I made a mistake. What did I do wrong? Well, if you aren't able to explain that in some way and show your work, that's what showing your work's for. So you can go back to see where you make a mistake. Because a mistake could literally be, like in this case, you didn't write down a negative. Or maybe you did, but your pen was fading out at that point, and then you got distracted, and then you didn't remember what you're doing at that time, and you go back to your work, and you're like, okay, you keep using positive 0.07, you're like, something's not, it's off in my equation now. What's going on? You go back and look at your work, and you see why, instead of you just wrote down that and you moved on. It might take a little longer to catch. All right, so anyway, that's solving equations using multiplication and division methods. And I think I'm going to see you later.